Hello everyone, today we're going to do 9.2, which is going to end up being solving quadratic equations by factoring. So our first example here, we're going to connect everything back to what we've done in the past. So we have graphed quadratics for quite a while now. We're going to take our equation and we're going to find our vertex by doing negative b over 2a. When we do this, we get our x value of our vertex to be negative 6. So it's going to be negative 6 comma something. To find our y value, what we're going to do is we're going to plug in negative 6 for x. And when we do that, we're going to simplify everything, and then we're going to get a y value of negative 1. So we're going to graph negative 6 comma negative 1. From there, we do our stretch, which is our a value, times 1, 3, and 5. So this one didn't have a stretch other than just your normal 1, 3, and 5 pattern. This is the graph of our parabola. As we can see here, our x-intercepts are where our graph is going to cross the x-axis. There are two different spots here at negative 7, comma 0 and negative 5, comma 0. When we look at these x-intercepts, what we did yesterday with 9.1 was we learned that these are the solutions to the equation when y equals 0. So an x value of negative 7 and an x value of negative 5 both would get y values of 0 when you plug them into the equation. What we want to do here is we want to compare that to your factored form. So as a reminder for factoring, when a is 1, we're looking for our number pairs. We're looking for what multiplies to get 35 and yet adds to get 12. If you like the x method, it is a 35 up top and a 12 down below. So you're looking for those number pairs. When you're thinking through them, you get x equals 7 and 5, because 5 times 7 is 35, and 5 plus 7 is 12. So our factored form here is going to be x plus 7 and x plus 5. The whole goal for today is to notice this connection right here. Our factored form was x plus 7, and our solution was x equals negative 7. Same thing with the positive 5 and the negative 5. That's not a coincidence. That is supposed to happen. You're supposed to be able to factor something and come up with your solutions as well. So that's the goal of today. Is our goal is to factor something and use our factors to come up with the solutions. And all of the factoring and everything relies on something called the zero product property. It means if you have two things that are multiplied together, like A and B are, the first one has to be 0, the second one has to be 0. So what that means is if we have a product, notice for number 2 here, we have x minus 9 times 5x plus 2. In order for this in total to be 0, either this first part is 0 or part is 0 because we're multiplying them together. So in order to find our solutions, what we're going to do is we're going to take this first factor, which is x minus 9. And if that equals 0, then the entire equation would equal 0. Likewise, we're going to take the second factor, which is 5x plus 2. And if that equals 0, then the entire equation equals 0 as well. And so what we can do is we can take and solve each of these equations to figure out those values of x that would make that factor equal to 0. So we end up with two different answers here. Either x will equal 9 or x will equal negative 2/5. And if either one of those is the case, then your equation is true and it does equal 0. So we have more than one answer. So that's the zero product property. You take each factor and you set it equal to 0 and you solve that equation. So let's look at the next one. Here there's three separate factors. Either 3x equals 0, 2x minus 1 equals 0, or x plus 3 equals 0. Those are our three choices. And so we're going to solve each of these different equations. So we're going to go ahead and divide by 3 for the first one and get an answer of 0. We're going to solve the next equation and we're going to get an answer of 1/2. And we're going to solve the third equation and we're going to get an answer of negative 3. So our three solutions for this one are 0, 1/2, and negative 3. So that's the zero product property. So now what we're going to do is we're going to look at equations that aren't already set up in factored form. We're going to have to solve it by factoring. So in order to solve by factoring, the very first step is always going to be to get the equation equal 0. So for this first one, we're going to subtract 64, and we get x squared minus 12x minus 64 equals 0. The second step here is going to be to factor. And so for this example, we notice our a value here is 1. So we're going to do our number pairs for this one. Each method of factoring is going to be different. You're supposed to look at an equation and be able to identify which method of factoring to use already based off of the factoring review we've done in the Chapter 8 stuff. So with our number pairs here, multiply -64 and yet adds to get -12. You can use your X method if you'd like to organize it that way. So you're looking for those number pairs that multiply to get -64 and yet add to get -12. It's going to end up being -16 and a +4. So if we were to factor it, we're going to write x minus 16 and x plus 4 equals 0. So that's step 2. Step 3 then is to use the zero product property. In essence, you're going to set each factor equal to 0, and you're going to solve the resulting equation. So we're going to get x equals 16 and x equals -4. Those would be our two solutions for this problem that when you plug them in, you get a true equation. So let's try another one. The process remains the same. Number 1, get the equation equal to 0. That is already done in this case. Step 2 is going to be to factor. So this one has a number out in front. And also, if you look at all of these, it actually has a GCF. So that's the first thing we're going to do. We're going to take, and we are going to take the GCF of 2 out of each of these terms here. So it's going to end up being 2x squared plus x minus 6 equals 0. Now from here, you can use guess and check or split middle term. It all depends on which method you prefer. I'm going to show the guess and check method. So I'm going to bring down my GCF from before. I'm going to try to figure out what my factors are. My first two numbers, here and here, are going to have to multiply to get 2x squared. There's not a lot of choices. It's going to have to be a 2x and an x. My next two numbers are going to have to multiply to get a 6. So my guesses can be 1 and 6 or 2 and 3. It all depends on what you want to choose. I'm going to go ahead and choose 2 and 3. And because there's already a 2 for my first number here, I cannot put a 2 here because I already took out the GCF. So therefore the 3 is actually going to be what I'm guessing for that one. And I'm going to put a 2 in the other one. And so here's the check portion. These two, when you multiply them, would be 4x. These two would be 3x. Hey, that's going to work out as long as 3x is negative and 4x is positive. And if that's the case, then the -6 also works out. So it's going to be a -2 and a, oh, nope, flip that. It is going to be a +2 and a -3. So step 2 is to factor. Step 3 is to use the zero product property. And so looking at these, we're going to set each factor equal to 0. So something interesting happens here. When we set 2 equal to 0, that does not yield a true statement. 2 does not equal 0, and it never will. So this first step of the GCF, there was no x with it. It's just a number. So it actually does not yield a solution at all. So then we look at the next one, 2x minus 3 equals 0, and the last one, x plus 2 equals 0. If you solve each of those equations, you end up with 3/2 and -2 when you take the time and solve for x. Okay, so those would be our final answers. We only have two answers again because our GCF did not have an x with it, and therefore there was no solution for that portion. So let's try number 6. So get the equation equal to 0. That is done. We're going to factor out our GCF first. Looking at our two terms, they both have an x in common. So I'm going to take that x and divide it out, or factor it out. This portion that's left here, we're going to use the difference of two squares. And so we're going to bring down our GCF from before. The difference of two squares works when you have a perfect square for the first term, and you do. You also need a perfect square for the second term, and you have that. And the last thing you need is you're going to square root the first term, square root the last term, and write one factor with a plus, one factor with a minus. Now this is still equal to 0. It is factored. We are going to go ahead and set each part equal to 0. This first part has an x, our GCF has an x, so that actually yields a solution. The next one, 3x plus 4 equals 0. We're going to subtract 4 and divide by 3, so x equals negative 4/3. And our last factor, we set it equal to 0. We solve that equation, and we get positive 4/3. So looking at this, we end up with 3 answers for this one. And if it helps, whatever the highest degree is in your equation, that's going to be how many solutions you get. So for this one, we got 3 answers. At this point in time, I'd like you to pause the video, try these problems on your own, and then keep on watching below to see if you got your answers the same as me. Okay, let's go ahead and check in. For number 7, if we follow our steps of getting the equation equal to 0, then factoring it by first taking out the GCF, and then after that we did our number pairs. And then using our zero product property, we end up with a GCF of 2. That does not equal 0, so it does not yield a solution. The other two factors, however, give us our final answers for this one to be negative 5 and negative 4. For the next one, same method. We take out the GCF, and after we take out the GCF, it's actually factored. We get x squared equals 0 and x minus 5 equals 0. We end up with x equals 0 and x equals 5. 0 happens to be a repeated solution, so if you're thinking, wait a second, she just said I should get 3 different answers because my degree is 3, 0 actually happens twice. So we end up with 3 answers like we're supposed to. So x equals 0 and x equals 5. For number 9, we got it equal to 0. We did our number pairs. We got x plus 8 twice. And so then we set that equal to 0 and get our solution to be x equals negative 8. Here's another example of it was repeated twice, so we ended up with 2 solutions here. So let's try one more example here where you have to do guess and check in order to factor this one. It's already equal to 0. So another reminder for guess and check is the first numbers have to multiply to get 3x squared. It's going to end up being a 3x and an x for this one. The last two numbers have to multiply to get a 4. So you can either guess 1 and 4 or 2 and 2. It really doesn't matter which one you guess. I'm going to go ahead and guess 1 and 4. Let's see if this works. So here's our check. I'm going to have 12x and 1x. That one, I can see that's not going to work. So let's go ahead and change my guess then. So let's maybe try 2 and 2. Okay, so if I have a 2x and a 2x, my outer numbers give me 6x, my inner numbers give me 2x. Hey, this could work if the 6 were positive and the 2 were negative. And that would end up working out with that negative sign there with the 4. So here's my factored form. I'm going to set this equal to 0, each of the parts here. And I'm going to solve each equation in order to get my final answers for this one. And so as I'm solving this, I do end up with 2 answers. X equals 2/3 and x equals negative 2. As you can see, factoring can help us to solve problems where graphing would have been a lot more challenging with this one because our vertex would not have been nice. So we can factor and solve by getting things equal to 0, factoring, and then setting each factor equal to 0. Hopefully this helps, and have a good day.